Hello and welcome everyone to this tutorial session. In this video, we will understand about different types of exceptions which are available in Python. So we start off this video by giving an overview related to what are exceptions in Python. After this, we will discuss two major categories of exception. So very first is the built-in exception and second is the user-defined exception. And we will discuss about both of these exceptions in detail in this video. So without any further delay, let's jump on to our very first topic. So in one of our previous sessions, we have discussed about errors, in which we have discussed some of the basics related to exceptions. So basically, exceptions in Python are errors which are not caused by any programming error. Instead, the code is unable to operate due to a mistake in the real world. So even though a statement or an expression in a Python program is accurate, it may produce any error when implemented. So exceptions in Python are errors which are recognized during the execution, but these errors are not fatal. We can operate them. Now there are two major categories of exceptions. So very first is the built-in exception. Let's discuss that. Now all the exceptions in Python are objects that belongs to the exception class, and this exception class is a subclass of the base exception. So almost all the built-in exception classes in Python are subclass of exception class, which is a subclass of a base exception class itself. So here you can see the representation of this. So here base exception is the parent class, which consists three subclasses. So system exit is there, keyboard interrupt is there, and exception class is there. Now all the built-in exceptions comes under this exception class. So now following are some of the most common built-in exceptions in Python. Now very first is this assertion error exception. So the Python interpreter returns this exception when an assert statement fails. Now after this there is one attribute error exception. Now this exception is returned when the attribute assignment or reference goes wrong. Now there are more than 25 built-in exceptions available in Python. You can read about all of them from the PDF available with this video. Now to understand these built-in exceptions, we will discuss few examples. So I will open my Jupyter notebook. So very first, we will discuss about this module not found error exception. So this exception basically occurs when we try to fetch any module which is not available in Python. For instance, I want to import this guides module, but this guides module is not available. So if I try to execute this, the Python interpreter will return this exception module not found error, and it is indicating that no module name guides is available in Python. Now after this, let's discuss about one more error, which is type error. Now this exception is basically returned when a function or an operation is applied to an object of incorrect type. So for instance, we have defined two variables here. Very first is this x, which is of integer data type, and y is of string data type. So I'm just recalling this thing that Python is a dynamically typed programming language. So when we define 18 to x, it will automatically define itself as a integer type variable, and in the same way y will be automatically considered as a string type variable. Now after this, we are trying to concatenate both of the variables, so we are using the plus operator between them. But in Python we cannot directly concatenate or add string or integer type data. So let me execute this cell. So when I execute, the Python interpreter will return this error, type error exception. Now next, let's discuss about this index error. So this index error will occur when we try to fetch any element from any index, but that index is not available in that sequence. So in that case, this index error will be returned. So for instance, here we have defined this names list. Now this list contains three elements. So the index will go from 0 to 2. So James is at index 0, then Robin is at index 1, then Jack is at index 2. After this, we are simply using a print function, and within the print function, we are using the index operator to fetch the element given at index 4. But in the list, we can see that no element is defined at index 4. So when I execute this cell, it will return me this exception, which is index error, list index out of range. So now let's move forward and let's look at the next topic. So next, let's discuss about the user defined exceptions. So till now we have seen there are variety of built-in exceptions like the index error, import error, zero division error, and many other which are available in Python. However, there are many instances when standard exceptions are insufficient and we must develop some custom exceptions to better manage the failure and create more relevant exceptions. So here we will discuss two things. So first we will discuss how we can create a user defined exception, and then we will discuss how we can use that user defined exception. So let's first discuss how we can create it. Now to create or define a user defined exception in Python, we need to drive a new class using the built-in exception class either directly or indirectly. Moreover, according to the standing naming conventions, a user defined exception should finish its name by the word error. However, this is not always compulsory. So initially I have shown this hierarchy. So to create a user defined exception, we need to derive a new class from this exception class. So basically we need to create a subclass from this exception class, and how we can do this. So let's discuss one example related to it. So here you can see one example. Now to define a new class, we use the class keyword. First, we are using this class keyword to define it as a class, and after that we need to define the name of the class. Now according to the standard rules, the name of an exception, user defined exception, should always end with a error. So that's why I have defined the name as zero value error, and then within the parentheses I have defined this exception. So I am basically deriving this class from this exception class, and then I have defined this docstring using the triple quotes, and within this class I have defined this print statement, value can't be zero. So in this way we can define our custom exception. Now after defining the custom exception, the next step is to understand how we can use it. Now in Python, we generally utilize the user defined exceptions based upon certain condition, and for this we need to raise or throw an exception. And for this task, we use the raise keyword followed by the name of the exception. So let us understand this thing with the help of example. So here we have defined this small program where we are using the zero value error exception. So what we are doing in this block of code, first we are taking an integer value as an input from the user and we are storing it in the x variable. After this, we are simply calculating the factorial, but before calculating the factorial, we are using the if else block to check whether the given number is 0 or not. So the factorial will be calculated only when the value is not a 0, and when the value is 0, then this exception will be raised. So that's why we have defined this raise keyword. After the raise keyword, we have defined the name of the exception, and if we want to pass any custom message with the exception, we can pass it within the parenthesis. So I have defined this custom message which states value can't be 0. So let me execute this code block and let me put 0 as an input. Now here you can see when I put 0, this exception has been returned. 0 value error, and in the last the exception is stating that value can't be 0, and this value can't be 0 came from this custom message which we have passed as an argument to this exception. So with this we have come to the end of this tutorial session. You can read about different exceptions available in Python from the PDF file which is available with this video. Now in the next video we will discuss how we can handle all these exceptions. So thank you for watching. We will see you in the next one.